Okay. So names and symbols of ions we should be knowing. So here, name of the ion and symbol. Let us take the metal list first. So metals with the +1 charge. Sodium +1, potassium again +1, silver +1, copper +1, magnesium, calcium onwards. Okay, magnesium is the second group element. So magnesium Mg+2, calcium Ca+2. Then copper is there. Copper also exists in the +2 form. So it is Cu+2. Then you have iron, ferrous we call ferrous. Okay, so it will be written in bracket. What is the charge? So +2. So here it shall be Fe+2. So these are the ions with the +2 charge. Then we have +3 charge also. Third set. Third set, aluminium. Aluminium is that. Aluminium Al+3. Al+3. Also, ferric is there. Iron. Iron also exists in the +3 form. Iron exists in the +3 form. So, Fe+3. So, these are the ions with +1, +2, and +3. So, these are metals we have taken. The next set can be regarding the non-metals. The next set is non-metals. So in the non-metals, again with the -1 charge, the -2 charge, and the -3 charge. So here in the non-metals, with the -1 or the +1, -1 if you take hydride, H-1. Then chloride is there. Chloride is Cl-1. Bromide is there. So bromide shall be Br-1. All the halogens usually, okay, bromide. Then iodide you take iodide I-. So these are the non-metallic ions which have -1 as the charge. Then second set, where there is -2 as the charge. So one is oxide. Oxide shall be O-2. Then sulfide is there. Sulfide is S-2. Oxide O-2, sulfide S-2. Later, one more set is there. So with the -3 as the charge, so that will be nitride. N-3. So in all these what you have seen, there is only one single atom. Here also in the metals you can see sodium, potassium, magnesium, copper, whatever it is. Okay. So here it is silver, not magnesium. This is magnesium, calcium, copper, iron. So everywhere there is only one single atom that which is present. Even in the non-metals also, hydride, chloride, bromide, iodide, oxide, sulfide, nitride, only one single atom is present. But there are also ions with the number of different atoms. Those we call them as the polyatomic ions. So in the polyatomic ions again, you have 2 sets or 3 sets. Let's see. The polyatomic ions. Okay. First one, ammonium, you can say. In this ammonium ion, you have got nitrogen as well as hydrogen. So there the symbolic representation for that, NH4 and plus. Then hydroxide. Hydroxide ion we say. Hydroxide ion is OH minus. Hydroxide ion is OH minus. Then we have nitrate. we have nitrate. In this nitrate, nitrogen and oxygen. Okay, NO3 minus 1. Just minus also will do. So here, what is your observation? Your observation is it is not one single atom. There are 2 or 3 atoms which are present. Okay, at least 2 minimum atoms are present. The number again is more. In oxygen number is more there. Fourth one, after nitrate. So there is hydrogen carbonate. Hydrogen carbonate. Hydrogen carbonate HCO3 minus. HCO3 minus. Then carbonate ion you take. Carbonate ion. So here what has happened? All are -1 or +1. There can be -2 or +2 also. So carbonate ion when we say CO3 -2. Then we have sulfate. Sulfate. Sulfate is SO4 -2. Sulfate is SO4 -2. Then there is sulfite also. Sulfite. Okay, sulfite. SO3 and -2. SO3 and -2. So this was 6, this was 7, now the 8. So here these 3 sets, it is -2. Here these 4, they were -1. Now one more is left over, that is the -3. So that shall be phosphate. Phosphate. Phosphate is PO4 minus. PO4 minus. So what you have is these are the list. These are the list of metal ions with +1, +2, +3. Non-metal ions with a +1, +2, +3. And then this set what I have given just now, it is a polyatomic ions. Polyatomic number of atoms, not single atom. In the previous list what I gave, okay, metal and non-metal, there are only single atoms. But now here there are at least 2 different atoms. There can be 3 also. There can be 3 also. At least here 2 different atoms are present. So this will be the polyatomic list, polyatomic ion list. Now coming to the writing of the chemical formulae. So for writing of the chemical formulae, what do you require? Rules for writing chemical formulae. Then 1 or 2 examples we'll see. Time permits. Let's see some more thing. Okay. Now the next is rules for writing chemical formula. Rules for writing chemical formula. Okay. What is the first one? So you should be writing the symbols of positive and negative ions. Okay, writing symbols of positive and negative ions. Writing symbols of positive ion, that is cation, and negative ion, that is anion. The magnesium, capital M, small g. Calcium, capital C, small a. Carbon, capital C. Boron, capital B. So those all are cations. Similarly, Cl minus or Cl, that is capital C, small l, that will be chloride. Capital B, small r, bromide. Okay, so those symbols you should be writing. Then what is the method of writing that symbol? Okay, now suppose you want to write sodium chloride. Sodium, you will be writing here the symbol when you are writing sodium this side, chlorine this side. So whatever cation is there to the left side. So I'm saying like this is left side, this is right side. Okay, right. So this is left side, the cation, and right side, the anion. After writing the symbol, what is the next step? You have to write their valencies. So the next, where and where the symbols are written. Okay, that we'll know. So first you should be knowing the symbols. Okay, positive, negative ion, whatever symbol is there. So writing of the symbols. So cation is written to the left. Cation is written left. This one. Then anion is written to the right. Anion, if you take, it is written towards the right. Cation is written to the left side, anion is written to the right side. Once this is over, then below that we have to write the valencies. Okay, writing of their valencies. Writing of valency below the symbol. Writing of valency below the symbol is the next one. Okay, so now for this example, sodium it is +1. Sodium it is +1 or just 1 we can write, and chlorine is also 1. You can write 1 and 1 itself. So since here valency for both of them it is 1 and 1. So when you cross them, okay. So for this reason, it's something like taking the LCM. Okay. So when you cross them, so what is the overall symbol that you get is NaLC. Okay. After crossing, you can write the valencies there, and that will be the next step that we have. So writing of the valency below the symbol is the next work. So here you have written the valency. This was simple example, sodium and chlorine 1:1. Then finally you write the formula there. So after writing the valencies, what you have done? Cross the valencies. Okay, important work is cross the valencies and remove the common factor. Cross the valencies, remove the common factor. Cross the valencies and remove the common factor. So there you get the whatever the molecular formula is there. Okay. So once you cross the valencies and common factor. Here suppose, okay, in this suppose there are some polyatomic atoms. Polyatomic ions are present. So whatever the common number is there, okay. So the number of whatever the ions are to be written. So those will be written outside the bracket. Number of ions written outside the bracket. Written outside the bracket. So if at all polyatomic ions are there, say for example OH ion is there. Okay, OH ion. So in the case of sodium hydroxide, no problem. Since it is only one ion, it need not be put a you need not put a bracket. When you come to magnesium hydroxide, so magnesium donates 2 electrons. Those 2 electrons are taken by 2 hydroxide ions. So you will be writing outside the OH 2 as a subscript. So for polyatomic ions, you have the bracket for that, and then whatever the crossing of the valencies is required, then you write down that number. So they are removing the common factor. So here this donates 2, and those 2 are taken up by 2 hydroxide ions. So outside the bracket as a subscript we are writing. Similarly, one more, aluminium hydroxide, AlOH thrice is there. AlOH thrice. Okay, so AlOH thrice. So OH is after the 3 is written outside the bracket. Further, if at all number is 1, here number was 1. Okay, number was 1. We need not put the bracket. Directly we can mention it as NaOH. So for the first group, whatever hydroxides are there, just the NaOH, KOH, LiOH directly we write. We don't mention the bracket and other things. Okay, fine. So these are the basic rules. Once again, let us see. So what we have done in the writing of the molecular formula, I shall take examples. So rules for writing the chemical formula. First is writing symbols of positive and negative ion. Whatever sodium and chloride ion symbols are there, or any other atom, whatever you are taking. So those will be written there. Once the symbol is written, where they have to be written? Okay. So left hand side you have to write the cation, right hand side you have to write the anion. Left hand side cation, right hand side anion. Then writing of the valency. Okay. So whatever their valency, just now I showed you before this list, I gave you the list of few of the metal, non-metal, and the polyatomic ions and their valencies. So those valencies have to be mentioned there. Okay, writing of the valency below the symbol. Once the valency is written, so you have to see the matching there. The crossing of the valencies is to be done, and if at all any common factor is there, that has to be removed. The minimum number. Now here it was 1 and 1, so that is removed. So you are not writing here Na1Cl1. No. So just as it is you write. Even if it is 2 and 2 also we don't write. Okay, there also we don't write. So then once you cross the valencies, then you are removing the common factor. The polyatomic ions, if they are present, like OH or maybe ammonium, or even there is phosphate. For that, so you write it in the bracket, and outside the bracket, whatever the number is required for crossing that valency and other thing, that will be done, and it shall be finally mentioned. Okay. Now let us take up 1 or 2 examples of these. What are the valencies? Let's take up few of the examples. Calcium oxide is there. Calcium oxide. So symbol, valency. Then the formula. Symbol calcium and oxygen, valency +2, 2, and this also is 2. Valencies are 2 and 2. +2 -2 you can be writing. Okay. Then when you cross this, so both are same. So 2 and 2. So you will be getting calcium oxide as CaO. Okay, both are 2 and 2. So when you remove the common factor, this becomes 1, this also becomes 1. When you remove the common factor, once again see, symbol is calcium and oxygen. Valency, if you take, it is +2 and -2. Then when you remove the common factor, this is 1 and 1. So formula shall be CaO. Then calcium hydroxide. Calcium hydroxide. So calcium symbol Ca, hydroxide is OH. Calcium symbol Ca, hydroxide is OH. So valencies, if you write, this is +2, this is -2. +2 and -1. So when you cross, OH should be how many? OH should be 2 and 2 should be 1. calcium should be 1 and hydroxide should be 2. So formula will be CaOH. Okay. So whatever this 2 is there, that will be with the OH. So OH twice and CaX. Further, sodium nitrate. Sodium nitrate. So in the sodium nitrate, first of all sodium Na and nitrate is NO3. Then again, what are their valencies? Valencies are +1, -1. Cross these. Okay, both are 1 and 1. Both are 1 and 1. So formula shall be NaNO3. Formula shall be NaNO3. Magnesium chloride. Magnesium chloride. In the magnesium chloride, Mg and Cl. Okay. Then +2. This is -1. So when you cross, chlorine should be 2, magnesium should be 1. Magnesium can donate 1 electron, magnesium can donate 2 electrons, and those 2 electrons can be taken up by 2 different chlorines. So it should be MgCl, MgCl. Last one example. Sodium carbonate. One more example. Sodium carbonate. So sodium Na, carbonate is CO3. Charge over that, if you write, this is +1, this is -2, and then when you cross, so carbonate will be 1 ion, sodium are 2, so formula shall be Na2CO. Okay, so with this we'll wind up for today. So whatever tomorrow's test is there, it is up to this, whatever the subtopic we have covered. So in the next class, Monday's class, we shall go with the covalent bonding. Thank you.